Hello, this will be our example 5 for exact first order differential equation, and this has initial condition. As you can see, we already have initial condition on separable and linear, so we already know how to handle that, right? Okay, and it also have a two more step, so we have to make that specific solution. After we use the initial condition, we have to make that solution explicit, and we have to find the domain of that solution, or another way, the interval of validity of the solution. So we'll think about that later. Let's just find the general solution first. So you always start by identifying m and n. So let's write it down. So my m is 9x squared plus y minus 1, and the n is negative 4y minus x. I know I will always distribute that and just write x minus 4y. It's easier to handle. So let's check. We have to check the partial of m with respect to y. Is it equal to the partial of n with respect to x? And you can see the partial of m with respect to y is simply 1, because the 9x squared is 0, is a constant, and negative 1 is 0. So all I have is the derivative of y, which is 1. The partial of n with respect to x is also 1, because the negative 4y will be 0, because that's a constant. So it is indeed exact. So let's try to find the potential function. So you start by writing the partial of phi with respect to x is m. In this case, the m is 9x squared plus y minus 1. And the partial of phi with respect to y is n, which is x minus 4y. So we will use the way number 3 from example 1. So make sure you watch it if you have not watched this before. So for the first equation, we're going to integrate both sides with respect to x. And here we're going to integrate both sides with respect to y. So this WRT will stand for with respect to. Okay, so let's proceed. So when you integrate both sides with respect to x, you get back the original phi. Remember, x is the variable, y is like a number, and you're taking integral, not derivative. So the integral of 9x squared is 9x cubed over 3 plus the integral of y is a number. So the integral of y is yx, just like the integral of 5 is 5x. Integral of 3 is 3x. Integral of y is yx or xy, minus the integral of 1 is x, and then plus any function of y could be my constant. Similarly, in this side, if I take the integral with respect to y, I get back the phi. Let's take the integral with respect to y. Remember, y is the variable, x is the number. So the integral of x is xy, minus the integral of 4y, I have to copy that 4, and the integral of y is y squared over 2. So let's simplify. I forgot, plus any function of x. can be a constant there. So let's write that down. So here, simplify here. So now we compare them. Any cross term must appear in both of them. So cross term means term that has both x and y. So look at here, I do have a term that has both x and y, right? And that appear in both of them. So let's write our final answer for phi. So I cross it out and write xy. Is there any other cross term? No. So everything else you copy. So let's copy everything else. So I have this 3x cubed minus x and then minus y squared minus 2y squared. So that's my phi, and this general solution, which is going to be an implicit solution here, is phi equal to c. But we're not done. We have an initial condition. So let's look at the initial condition. My initial condition is y of 1 equal to 0. So let's do that. Y of 1 equal to 0. And again, you can do this using GeoGebra geometrically. Remember, you create a bar for C and you move the C around, and this initial condition means the graph has to go through the point 1 comma 0, because here the x is 1 and y is 0. So we're looking at the point 1 comma 0, and for what value of c the graph goes through 1 comma 0. So you can approximate the value of c, but in this case we're simply going to use algebra to save some time. If you're interested, look at some of my previous examples, and some of the examples you're going to find this way of finding c. But right now, simply substitute x equal to 1 and y equal to 0. X equal to 1 and y equal to 0. So we simply substitute x equal to 1 and y equal to 0. And that's supposed to be equal to c. And that gives me the c. This is 0. This is 0. So my c is equal to 3 minus 1, which is 2. So I have to go back and plug this in place of c. So that's going to be my specific solution. It's still implicit. So this is the implicit specific solution. And this is the general general implicit solution. So both are implicit because y is not solved in terms of x, right? So that answered part of this question. But now the question also says we have to find the y explicitly. Can we do that? Can we find the y explicitly? So let's do that. Here we did something similar before. So we're thinking y as a quadratic equation. So we're thinking this as a quadratic equation in terms of y. So let's rewrite. So that's my y squared term. That's my y term. And everything else is a constant. So everything else I'll copy. And I'm going to move this 2 to the other side. And then we can use the quadratic formula to find out um, dy. So let's do that. So here we're thinking this, so ay square, so that will be my a, bx, I mean by, so that will be my b, and my c is this constant. So that's my abc. And remember the quadratic formula, right? Is minus b plus or minus square root of b squared minus 4ac divided by 2a. So just substitute ABC here. So you substitute A equal to -2, B equal to x, and C equal to 3x cubed minus x minus 2. So don't confuse this C with the C above. So it's a different C. So let's do that. Minus B plus or minus square root of B squared minus 4AC divided by 2a. So let's simplify. So this will be plus 8. So let's multiply this out. So I'm going to write the inside from the higher exponent to the lower one. So I'm going to write this 24x cubed in the beginning, and then plus x squared, and then minus 8x, and then minus 16 divided by -4. So, and that's an explicit solution, but we have to decide which one. Is it plus or is it minus? So let's think about that for a minute. In fact, I can distribute this -4. Let's actually do that. Uh, Let me add a blank page. 1 second. Okay. Okay, so let's do that. So let's actually distribute that -4 under each one. Okay. So negative x divided by -4 is just simply x over 4. And then when I distribute, it still is going to be plus and minus. Okay, very good. Now remember, if you look at the initial condition, right, my y is 0 and my x is 1. Okay, so the graph has to go through this point 1 comma 0. So here you can use some help of a GeoGebra or some other graphing utility. But before I actually do that, let's answer the second question first. Let's answer the second question here. It says find the domain of the interval, or validity. So here, doesn't matter which one you choose, which branches you choose, plus or minus, right? The domain will be determined by the inside of the square root. So we want domain, we want x so that the inside the square root I have positive. So the domain will be all value of x for which the inside is positive, bigger than or equal to, it could be equal to 0, no problem. Okay. So how we solve it? Of course, we are not going to do it by hand. So here you can use GeoGebra or other computing algebra system in computer. And let's actually use Wolfram Alpha. So I'm going to show in my here. So let's actually use Wolfram Alpha here. It's actually very useful website. So here it's actually more capable of doing algebra, and GeoGebra is more capable of doing geometry. So Wolfram Alpha is for algebra and GeoGebra is for geometry, although both can do all of this. So I feel more comfortable using Wolfram Alpha for algebra. So let's actually ask Wolfram Alpha to solve this inequality. So I want this 24x cubed plus x squared minus 8x minus 16 to be bigger than or equal to 0. Let me just write bigger than 0 and see what I get. Okay, so I get this solution. X has to be bigger than this number here. And that's like an exact answer. So let's copy that in our note. So the domain is all value of x as long as x is bigger than that number. So let's put it here. So x has to be bigger than this number, whatever that number may be. But we want some decimal approximation just to make more sense. I mean, we don't have any idea what is that number approximately equal to, right? So let's actually ask Wolfram Alpha to give us an approximate value. For that, you can actually enclose this by the function capital N. So capital N represent a numerical solution. If you enclose something by capital N, it will give you a numerical solution. So let's do that. So, so my numerical solution is this one. So let's actually copy that also. And you can see it also gives you a graph, right? Where it intersects x-axis. And that is this point here. So I'm going to also copy it here. So you can see there's an exact domain and an approximate domain. So this is like 0.984587. It's actually continuous. So the computer round off. So that's good enough for us. Okay, it's actually very close to 1. Can you use GeoGebra? Yes, you can. Let's actually use GeoGebra. So let's go ahead and use GeoGebra. Okay. That's a little bit tricky. So we want to know when inside the square root is bigger than 0. So let's actually graph that function. 24x cubed plus x squared minus 8x minus 16. And you see that it intersect x-axis at this point here. It looks like 1, but it's not really 1. It's close to 1, right? We know that. We want to know where is that intersection, right? Where the graph intersect x-axis, because we want this to be bigger than 0, right? So it's above x-axis. So we want to know where it intersects this x-axis. So let's zoom in. And you have to zoom in quite a bit. And you can get some approximate idea, right? When you zoom in more, and there's a limit how much GeoGebra can zoom in, but you can approximate, right? You can approximate. So it's like a more than 0.984 and less than 0.986. It's probably close to 0.984 3, something like that. Okay, but at least you have some approximation. So you can, let's actually see how much the GeoGebra can zoom in. Quite a bit actually. I'm very impressed. Wow, not bad. I'm keep zooming in. Oh my, okay, this is good. I never done that before actually. Okay, look at here, look at here. Okay, so that's too much. Okay, okay, I think that's good enough. Okay, so that gives you a very, very, very good approximation. At least it is correct to 3 decimal places, actually 4 decimal places for sure, right? Because uh, it's between 0.9845, and I also have it here 0.9845. So at least the 4 decimal places is correct, 0.9845. And look at our answer here. I do have 0.9845, right? The first 4 decimal, we can get it from GeoGebra. So that's another way of getting the answer. Now let's go back to this question. Which one should I take, plus or minus? So let's look at that. Okay. So I'm going to write both of them. So let me actually copy that here. Let's copy it here. Okay. So I have two possibility for the y, right? We can have y equal to x over 4 plus this, or I can have this. Now remember which one, but don't forget our initial condition, right? Let's go back to the initial condition is y of 0 equal to 1, right? Sorry, y of 1 equal to 0. Y of 1 equal to 0, right? So think about the initial condition, right? Y of 1 equal to 0. So this means my x is 1 and y is 0. So when you substitute this, x is 1 and y is 0 in both of them, right? Which one will give you 0? Let's think about that for a minute, okay? So if you look at this quantity here, right? This quantity, right? That we know has to be bigger than or equal to 0. Same thing here. This quantity is bigger than or equal to 0 because we already choose a branch of the square root here, which is positive here, right? Uh, so we're only looking at the circle part. So I know this is bigger than or equal to 0. This is also bigger than or equal to 0. So here, if I replace x by 1, I'm supposed to get 0 for y. And if I replace x by 1, I get 1 over 4 plus something which is bigger than or equal to 0. So this cannot be true. Here, if I replace y by 0 and x by 1, I get 1 over 4 minus something which is bigger than or equal to 0. So this is a possibility that this can be this can be 0, and indeed it is 0, because if this is 1 over 4, then this will be the whole thing, it will be 0, right? 1 over 4 minus 1 over 4 is 0. And you can check that if I replace x by 1 inside the square root, if I replace x by 1, what I get? So let's see if I replace x by 1 inside the square root, right? So that will be 24 plus 1 minus 8 minus 16. So this is negative 24 will cancel out with the positive 1 and you end up with 1. Look at that. So I end up with 1 over 4, right? So it has to be this one. So without actually any graphing, you can argue that the correct explicit solution will be this one. So this branch we're supposed to take with the negative sign. Always remember, you can do it. Thank you. Bye bye.